Um, so we're back. We're doing we're doing the second video for the Groot language model. Um, Today's video is a little bit new, I guess, because I haven't done, or maybe we're bringing back an old thing. I haven't done a video where I'm strictly speaking to voice chat in a while. So the motivation is the fact that the GLM was vibe coded, even though we understand like the architecture behind it. The actual Python stuff of like using like data classes, you know, I don't think I've ever actually used a data class in Python. So how do I say? All of the small things of like the actual code level implementation are abstracted from me, and our goal today is to, you know, alleviate relieve ourselves of a bit of that abstraction. Um, so Tony, whatever we're going to call the voice, is going to um, give me a tour. So before I started this video, I confirmed that the Llama 3 implementation for my class is actually in fact similar to our GLM implementation, and the only difference is that, well, GLM I can actually run on my CPU instead of renting compute from Colab. So that's awesome, is we're using like the same fundamentals, and the main difference is that, like, how do I say, like the embeddings and like the embedding weights rope is done a little bit different. And then the LM head, it's like hard coded in the implementation from class. But what Vault Chat Vibe coded was, how do I say, it leaned on PyTorch. So we're gonna go over the code because it's the structure and like the, how do I say, the data structures going on in the background. Like, for example, the, like, for the optimizer and the gradients and all that kind of stuff. That's something that has to like persist through training and whatnot. And even though I understand that it has to, like, what does that actually look like? So we're gonna go through a tour. Today's video might be extra boring, but I need to, today, instead of me actually like recalling, producing, and like thinking through things, today is more so about me consuming information. And that's, I don't know, that may be a bit harder to watch. But hopefully the fact that I'm talking to an AI, you know, maybe you're listening, maybe this is like podcast-esque, you know? So let's see. Hi, Tony. How are you?
I am doing well, thank you. I am ready to start our guided walk of the model whenever you are. Just let me know when you want to begin.
Okay, yeah. So you have the tour.md. I would like for you to, I want you to internalize that as your context. That's your brain, as the document says. And then I want you to walk me through the code. And then obviously I'll end up interrupting you whenever I get confused, and we can sort of have a back and forth. But, I'll be the judge. Just start guiding me and expect to be interrupted. Hello.
I am here. I just scrolled our view to stop zero in the tour document, which is config.py, the design surface. Every single knob for this entire system lives in this file, and no other file hardcodes any sizes. You will see parameters like dmodel set to 128, nhead set to 4, nlayer set to 4, and the training block with batch size 16 and sequence length 32. Here is your first poke question. Head dim is not stored as a field in this config. Where does it come from, and what enforces that it must be a whole number?
Um, how do I say this? Head dim is obviously going to come from d model divided by n heads. I think that's a weak thing to poke at me for. So make sure when you do the rest of the document, you should be coming up with the pokes on the fly, and they should be stronger than that. They're not, supposed to be, do I understand division? Um, my question is n layers. Is that parameter supposed to capture the layers we use in the feed forward neural networks, or is it the number of transformer blocks that we're copying? Um, the fact that we're using n heads must mean that we're doing multi-headed attention, And the max sequence length I find quite interesting. Um, so how do I say the curriculum, I guess, for the training run? The way I understand it is, sequence length is arbitrary. So, you know, you can give any size input of whatever sequence length, and that won't really affect things. Why, I'm curious as to why we're maximizing or why we're setting a bound on the sequence length for training, and as well as, when that comes into play.
Fair point on the division question. I will make the pokes much sharper and more conceptual as we go. To answer your first question, N layers is the number of full transformer blocks we stack sequentially. Each of those blocks contains its own multi-head attention layer, followed by its own feed-forward network. It is not the number of layers inside the feed-forward network itself, which is just a single two-layer projection. To your second question about sequence length, while attention mathematically can accept any sequence length, we have to set a hard bound because of how we inject positional information. In this architecture, we use rotary position embeddings, or ROPE. ROPE requires us to pre-compute a table of complex rotation frequencies up to a maximum length. If you pass a sequence longer than max seclin, the model will look for rotation angles that do not exist in that pre-computed table, causing an out-of-bounds error. Additionally, memory scales quadratically with sequence length during attention, so setting a bound keeps our
Wait,
GPU memory.
I find that quite interesting. Why can't the table for rope, sort of just like expand with sequence length? Is it because then that breaks the consistency of the math of the model? Like sequence length or your scores matrix can like expand to an arbitrary size and that's irrelevant. But how do I say? The multiplication with the rope matrix is deterministic, and breaking that breaks the consistency of the math.
You're hitting on a deep design trade-off. It is not that expanding the table breaks the consistency of the math itself. The rotation formula is perfectly deterministic and can be calculated for any position index. The real reason we pre-compute a fixed table is speed and GPU efficiency. Calculating trigonometric functions like sines and
Okay,
cosines.
so yeah, so once again, this max sequence length is that has nothing to do with mathematical bounds. That's just a practical compute engineering design choice.
Exactly. It is
Okay,
a pure
then
engineering optimization.
what's it
We
called?
pre-compute
I want to, as we go through the rest of this, you know, I want you to be able to show me when that comes into play, when that becomes significant. Um, let's see. But so I'm supposed to be able, I can open the config.py and I have it open now. It's just a, how do I say? It's just a class. It's just an object. When does it get called? Like what file is going to call or create a new config object? Is it train.py or something like that?
Yes, train.py is the main entry point that instantiates this config. It creates a single GLM config object and passes it down to the tokenizer, the data loader, the model, and the optimizer. Let us move to stop one, which is tokenizer.py. This is a byte-level, byte pair encoding tokenizer. It has two
Wait,
stages.
no, I don't think you've moved on too quickly. I don't think I'm past the config.py file. I don't think we need to go line by line, but you need to go into better detail of the content of this file.
Understood. Let us slow down and look at the rest of config.py together. Beyond the architecture knobs, you will see a training block at the bottom. It defines parameters like max steps, 2000 in Loro E4, weight decay, 0, and grad clip 1 die duo. Here is a sharp conceptual poke for you. We have both max seclen 64 and seclen 32 defined here. Why do we have two different sequence lengths in the config? And what would happen if we set seclen to 70 during training?
Wait, I actually do find this quite interesting. You're saying, how do I say? Okay, so this sequence length, we never even approach the bound. The max sequence length is just how large of the deterministic rope matrix, how large that matrix is going to be. But then training is, we're not scheduling doing inference on, multiple sequence lengths. We're only training for a single sequence length.
Exactly. During training, we slice our data into fixed-size chunks of SE sec len yo 32 to keep our tensor shapes uniform and batching efficient.
Why
But
don't
we
we
set
do why don't we do multiple? Why don't we do something like, why don't we start with a sequence length of 10, then 20, then 30, and so on?
We absolutely can, and that is actually a technique called sequence length curriculum training. However, in a standard simple training run like this one, keeping the sequence length constant at 32 makes the engineering much simpler. It means our batch tensors always have the exact same shape, so we do not have to constantly reallocate GPU memory or handle complex padding. But because we set max sec len bar 064, it means that even though we trained on length 32, the model is mathematically prepared to generate up to 64 tokens during inference. If we tried to set sec_len to 70 during training, the code would crash immediately at startup. The
Okay,
post-init warning.
but our loss in sort of sense of generalization is going to come from a sequence length of 32, meaning that by sequence length, I don't know, 40 plus, we're sort of in this uncharted territory. So you're depending on the fact that we've generalized, we sort of like generalized sequence length reasoning or whatever, sequence length generation, and that would extend into greater sequence lengths when that's not necessarily true. You're sort of just banking on that working.
You have hit on a massive open question in LLM research: length generalization. You are completely right. If a model only ever sees sequences of length 32 during training, it has never calculated attention scores or applied rotary embeddings beyond position 32. When we push it to 64 during generation, we are banking on the mathematical properties of rope to generalize. In practice, standard attention models often degrade or hallucinate when pushed past their training sequence length because the attention softmax distribution behaves differently with more tokens. Are you ready to look at how we turn raw text into these sequences of 32 tokens in tokenizer.pa?
Um, I don't know. Let's take a pause. If we kept going the way that I think we're going, I think that I would just once again have a high level understanding, which I don't need any help with. You know, I'm sort of more curious about what the underscore underscore post init underscore underscore self is doing inside of the GLM config. You know what I mean? Is and like, you haven't mentioned the paths that we're referring to. Is so what's the corpus path? What's the corpus for? You know what I mean? The tokenizer. We haven't gone over the tokenizer. If I were to open the JSON file, I would sort of see like pairings of indices of characters from the corpus text. You know what I mean? I don't understand that fully. That's more so what I'm expecting for you to explain to me than, just more high level of what's going on in an LLM. We don't need to go over that. So actually, I'm going to take a pause because our friend Tony is not doing the best job. So I'm going to have the actual agent in Vault Chat rewrite his brain. So let's see. All right. I think we need to change. Do you? Cool. Okay. one quick fork before I rewrite. I don't know what that means. It didn't say anything. Okay, so we're getting a rewrite of the tour, and then we're just gonna say resume. Um, that was eh. You know, I didn't want to do a video where I'm reading, because that's like, you know, like we're already doing something bad enough where it's just me talking to a voice. You know, if I were to like read this line by line, like who cares? And like for me, retention wise, I care about, you know, what I'm understanding and what I'm learning. You know, I don't use data classes. Let's see, post init, assert that, yes, that they're the same shape. Post init, self, how do I say, what is this doing? Sequence length must be less than, okay, so these are for errors. Post, oh, it's post initialization. So after you initialize the config is, this is just a classic thing that happens with data classes, I guess. It's a type check. Property, head dim to int, return. Okay, a property, I guess, of the, how do I say, you can't see this. A property of the, what are we calling this? The data class. Does data class let you create a data structure in Python? I don't know what a data class is. They seem quite useful. I've stumbled upon them a good number of times reading files like this. Um, property of headdim, which returns an integer. Okay. Self.headdim. That makes sense. And the object is the config. Oh, and it's because, okay, sure, yeah, is you want to return the number, the dimensions of the heads if you don't have it already. That's like a, okay, I'm okay with that. And then, okay, so this is really just a config file. This is like really just a configuration. So maybe we don't need AI. Maybe AI does suck. Let's see. We have the corpus. Okay, so then what are the files that are calling this, that are calling the config? The data loader's calling the config. The generator's calling the config. The model is calling the config. Let's see. The tokenizer is not calling the config. That's good. Let's see. Train. And the training file is calling the config. So everything is calling the config except for the tokenizer, which makes complete sense because the tokenizer is just data prep. Wait, pause. The tokenizer. Why does our config file, shouldn't our config file determine how we tokenize? I feel like if I were to design a config file, you should choose whether or not you're going to do BPE or that kind of things. Like what kind of vocab size do you want, et cetera, et cetera. That should be something you decide. Sample IAM group, we are a group. Yes, okay. So you verify that tokenizing works. Stage 1 is to learn the vocabulary. Stage 2 is apply it. Yada, yada, yada. Yeah, but there's just like so many helpers. And like, okay, merge. Okay, but what's merge doing? I don't want to read this. Let's see. Replace every occurrence of pair and IDs with a single new ID. You know? I want to like push boundaries, you know what I mean? It's like, I'm not, how can I ingest this without, you know, reading every line? You know? There's got to be a better way to consume this. And I think that a conversation would be quite nice if the AI did its job. Let's see. Tony, welcome back.
It is great to be back. Let us dive straight into the concrete mechanics of the code and the actual files you have open. Where would you like to start looking first?
You don't know where to start?
Let us start with the post-init method inside config.py, since you flagged that specifically. I will read the file to see exactly what it is doing. The post-init method here is acting as a runtime validation gate. It runs automatically right after the data class is initialized to enforce two critical mathematical constraints before any training or memory allocation starts.
Mhm.
First, it asserts that the hidden dimension.
Okay, but
First, it
this
asserts that
assertion doesn't really matter because, how do I say? The config, is it editable? It doesn't look very editable. You know what I mean? Is when you say like int equals et cetera, et cetera, et cetera, are those all the defaults? So when I actually create the config, I can do something else? Because, this, then, how do I say? Post init Sure, but you've also already defined things such that those conditions are true, so they're almost redundant verifications.
You are exactly right. For the default values written in this file, these checks are completely redundant because those numbers already satisfy the conditions. However, these are just default values. When you actually instantiate this data class in train.py or in a notebook, you can pass in any
Okay,
custom values you want.
so when is it actually instantiated, and where, you know, how is that instance shared across the training run and the other scripts?
Let us find exactly where it is instantiated. I will search for GLM config across the files to see where it gets called.
Hello.
The search timed out. The search timed out, but I can see from the file index that we have a train.py in the same directory. Let me read that file directly to show you exactly how the config is instantiated and passed around. In train.py, the config is instantiated right at the start of the main function with cfg glm config. From there, it is passed as a parameter to almost every major component of the pipeline. It goes to get tokenizer to find the paths and vocab size, to build tokenage to process the corpus, to group data set to handle batching and sequence lengths, and directly to the GLM model constructor to define the network architecture. This single object acts as the single source of truth, ensuring that the data set, the tokenizer, and the model are all perfectly aligned on parameters like sequence length and vocabulary size.
Oh, wait, this is interesting. Sorry, I didn't listen to a word you said, but it seems like, yeah, it gets initiated at main, but then it gets passed into every single. Oh, it doesn't get passed into everything. Interesting. But so like the configuration is instantiated at main, but then it's passed into all of these helpers that actually use the configuration. So, you know, exporting the loss curve for whatever reason uses the config. For example, like the cadence at which we actually save the files, that's part of the config, I believe. Overfitting on one batch. I wonder what that does. Oh, so the model, let's see, the model calls the config as well. No, 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 no. Wait, yes, it does. GLM. And we're importing GLM from model. And how does the model use? Oh, this is so strange. Model and how do I say it? Oh, so sort of let me pause. Is the reason that all of these files are importing the config because it's a data class, and the way you've written the code is you use signatures, for types of these functions. So it's not necessarily that the actual object is being used, but because it's a data type that we've defined, you're using it to accurately write your signatures of the functions, since those functions are going to be used in the config that's given to them when the helpers of that file are create or are pulled into the training.py.
You have hit on a very clean distinction. Yes, in files like model.p, we import GLM config primarily for a type hinting in the function signatures so that the editor and type checker know exactly what fields are available. But when the code actually runs, the model constructor, data GLM CFG vocab size, takes that concrete CFG object and reads its fields directly to build the network. For example, it reads cfg.d model to set up the embedding layer, cfg.n layers to loop and stack the transformer blocks, and cfg.n heads to configure the attention heads.
But that's
So it is
all
doing both,
that's
serving as a
all that's all inside of the training.py though. Is like the training.py is going to instantiate the model, and then the model is going to use the config that was also defined in train.py. It's just that we've isolated the files so that calling their objects into train.py is sort of well organized.
exactly. It is a clean separation of concerns. By isolating the model architecture
So
and
is the
model.
only files that we actually run are tokenizer and train and generate, I guess.
Yes, that is exactly right.
So
The only files you.
config is a data class. Data loader. Let's look at that real quick because data loader sort of has to actively do things, and there isn't a data class of the data set. So yeah, help me understand how batches are pulled in the data loader and how sort of like the state of what batches have been pulled to train on is maintained such that we don't we don't pull the same sequences over and over, or we don't overlap sequences either, unless we don't care about that.
Let us look at how Groot dataset handles this. I will read the rest of the getBatch method in dataloader.py to see exactly how it samples. The short answer is, we do not care about overlap or repetition here. In getBatch, the dataset picks BUA random starting indices anywhere in the flat token tensor using torch.random. Because it is completely random every time, sequences can and absolutely do overlap, and the same sequence can be sampled multiple times across different steps. There is no state maintained to track which tokens have been seen. This is a standard simplification for small-scale training runs on a single corpus, as the random sampling naturally covers the dataset over many steps without the overhead of tracking index partitions.
Okay.
Would you like to look at how the tokenizer encodes these tokens next? Or should we jump into the attention mechanism in the model?
No, I'm sort of curious. Something I'm curious about is if you could rewrite, you know, how do I say? So the scripts that we actually run are tokenizer, and that's because that's going to use the data set and that's going to produce our actually indexed data set and our, how do I say it, our token mapping. Um, Data loader, we're going to pause on that. Still a little bit confused with data loader. Generate, that is just so that I can speak to it in the terminal. We almost don't need it. Model.py. Model.py, there's nothing in model.py that's run. Model.py allows us to define the object of the model that's going to be called in train.py. Config is still a data class. Config.py is just the separation of the config object that we then use in train.py and pass into all of its helpers and the model as well. Um, and that's it. Config, data loader, generate, model, tokenizer, train. Okay, so that's all the files. That's all. That's pretty straightforward. Part of what I'm curious about is how much you could simplify this. Then is you're sort of using signatures. Do we have to use signatures in Python to do all of this? Do we have to? How do I say? I like the separation, but do we really need the type checking? You know what I mean? Is those are all good developer practices, but for the sake of me learning, they're almost noise to me right now. You know what I mean? Is I'm curious if we could refactor the code to do the same thing, but we got rid of the unnecessary amount of like helper and checking, et cetera, et cetera. So such that like every function and every data object has like a purpose and is like cleanly defined and more so readable, let me say, basic Python than using the advanced stuff. And then like when I go for my implementations, we'll build up to the motivation of the advanced stuff. Is why do I want type checks? I want type checks because I'm gonna choose my own config, and I don't want to enter a bad config and be confused why something downstream broke because of my upstream decision. That's why we have type checks. But right now, you're gonna write the code, or if some other agent wrote the code, I know it's going to be fine. You know what I mean? So, do you see where I'm going? Is give me a percentage of how much of the code could be stripped and simplified, and I may make that decision.
I see exactly where you are going. If we strip away the type hints, the assertions, the doc strings, the file-saving boilerplate, and the extra CLI arguments, we could easily cut about 40 to 50% of the total lines of code across these files. In Python, type hints and signatures are completely optional. The interpreter ignores them entirely at runtime. They are there purely for the developer's editor. If we refactored this to be bare bones, readable Python, we would have 1. A plain dictionary or simple class for the config with no post-init checks. 2. A data loader that just slices a list of numbers with no custom class wrapper. 3. A model that just implements the raw PyTorch tensor math without extra validation. This would let you see the load-bearing math and logic directly, without any of the engineering scaffolding getting in your way.
And
Would you like me?
it would function exactly the same.
Yes, it would function exactly the same. The neural network would train, the loss would fall, and the math would be identical. The GPU does not care about type hints or assertions. It only cares about the tensor operations.
Okay, so pause. So I think I might want to do that. You know, um, is we actually do understand like the purpose of every single file. I'm bad at programming, so all of the extra like proper being an engineer writing code is like, you know, it's not in my motivation right now. You know what I mean? Is like this isn't production. This is like I'm learning. You know, is like if I'm gonna build this from scratch, I'm not gonna do all that. You know, or I would only for the sake of debugging. You know what I mean? Is like I want I want the motivation to emerge for me. I don't want it to be right now. I don't see why. You know, I don't really have a why to do those kinds of things. They're not inherently necessary to me. I'm sure that they're necessary because they're best practices, but I want them to become best practices for me because I need them, not because they're called best practices. You know what I mean? So let's go for the refactor. Um, I think today was all right. You know, we didn't do too much. We have we have the config. It gets passed. Train.py is like and tokenizer are the only really things that get run. The gap that I have is like I'm asking myself, why is it that I don't feel like I could do this from scratch yet? And it's because there's too much like Python, sort of like more advanced stuff that like I don't frequently use. That's sort of like it's giving me a bit of like a mental gate. Is like, oh well, I don't know what's going on. You know what I mean? And I think if we got rid of all of that prettiness of like the all these checks, that even more so for Python, like Python doesn't actually use them. You know what I mean? And I don't use them. So like, let's go for it. You know, is the sort of stripped down version. If it's going to run the same, we should go with that. And suddenly I feel like I can read it. Suddenly I feel like, oh, I could actually reproduce this. Let me do this part, this part, this part, this part. And then I've done group from scratch, and then we can finally do coconut from scratch. Um, because I would argue, yeah, me doing coconut from scratch, if I don't need those type checks, I'm not going to do them. You know what I mean? Is like it should build up. So let's start the refactor. I'm going to ask for the refactor, and then this may take a while, but I think this is okay. This is very purposeful. Um, I'll be yeah. I'm just really hoping that it said 50% less lines of code. You know what I mean? Is and it's already not that many lines of code. Is if we can get like a clean version that's sort of just like very basic Python and things are named well, I think that's really good for my mental model of the code. So, okay, refactor and then call it a day. Let's see. Okay. Okay, dive deep. Do you know how to do this refactor? Hmm. Yeah, cuz like how do I say it? I don't know. Self-test the XY contract on a fake array, no tokenizer, no model. Like these comments mean nothing to me, you know? is like you can't just say whatever. Is like it needs the yeah, the action needs to emerge from a motivation. I'm not motivated by these things. So let's see. I know exactly what you want, of course. What you want? A single file? No. No, I don't want a single file. No type hints. Whoa. My focus is on. I want the same. With closer use. Okay. Yeah, it's like, because it's how many. Generate is so irrelevant, you know? It's all train.py, which is okay. So that's part of why model.py is so cool. But again, yeah, it's like strip out the noise. Type hints. Yeah, from future data class is a plain class config. Yeah, with values set in it. Property hidden. Exactly. 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 Yes. Wait, this is a real world factor across the whole file, file by file. Yes. Do a new folder and then test it. I don't know. I don't know how long we've been recording for. Then test it. I think I'll end the video before, so you guys don't have to watch me retrain the model again. That's it. And then test it. Okay. So I'll run that. I'll run that. I'll run that after the video. I think I'll take care of that. Cause okay, yeah. See, like, what are we doing? It's proposing a mission. You can't do missions anymore. So let's see. Pause. No mission. Go for it straight. Okay. So what does that mean for tomorrow? Tomorrow is the plain version. If things go how I'm expecting them to go, tomorrow will be the plain version of going over this code again. Um, we learned a little bit. You know what I mean? It's not it's not a complete waste of time, but this wasn't a like a dense session where like I recalled, you know, like the videos where like I don't know, I talk about like the transformer and then like oh I have two conflicting ideas that I think both of them are true, but obviously they can't both be true, which forces me to learn something new. You know, um, we didn't have that today. Um, however, we still, you know what I mean. My relationship with the files and what they do and the objects in the background is closer to the code. It's just not. I don't know. It's not impressively close. You know what I mean? It's not sufficiently close. Is I still don't feel like I could write these from scratch. So no, I changed. Blah 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 blah. So yeah, okay. I'll fix that after the video. And yeah, today was okay. Today's boring. You know, hopefully I have more fun. Hopefully we'll get to fun videos sooner, or back to fun videos sooner. I think. How do I say it? Ooh, yeah, Will, if you're watching, I think, these CS people are like, if you're crazy enough, crazy people, I don't know, people will be watching whatever on YouTube, if you're crazy enough to watch someone type code for 3 hours, I might do that, you know, and you can watch me struggle to type. But I have a feeling, that would hold me accountable. It's like, okay, so like there's a camera on me and I need to say everything I'm thinking out loud, you know? So yeah, I don't know. I would do everything from scratch. I'd have the whiteboard out. So hopefully that's fun. It's like, okay, we're going to do this. We have our data set. I would still be using Vault Chat because I'm not, that's so slow. That's so much work. But vibe coding function by function and like me still running the terminal is, that's the next step. You know what I mean? There's vibe coding the entire thing. There's vibe coding function by function. And I'm not even sure that I'll ever hand type functions. I may, but like that's what we have leak code for. You know what I mean? Like that's not the, like these are for projects. The goal of our project is like output and execution. It's not, can you code this from scratch? Um, it's like, okay, well I could do it from scratch, but it's gonna take me 5 times longer. So cool. That'll be tomorrow. Plain version. Super cool. See you later.